The deadliest volcano in the contiguous United States is not Yellowstone. It is not the caldera that gets the documentaries, the National Geographic specials, the million-view YouTube videos about what happens when a supervolcano wakes up. It is not the one with the geysers and the hot springs and the dramatic thermal features that 4 million tourists visit every year. The deadliest volcano in the lower 48 states is a 14,411-foot stratovolcano sitting 60 miles southeast of Seattle, Washington. It holds more glacial ice than any other peak in the contiguous United States, 2.9 cubic kilometers, spread across 26 named glaciers. It sits directly above river valleys that carry 4 million people in the greater Seattle and Tacoma metropolitan area. And unlike Yellowstone, which would require a full caldera-scale eruption to threaten that population, Mount Rainier does not need to erupt at all to generate one of the most catastrophic natural disasters in the history of the United States. Drop a comment right now. Did you know Mount Rainier outranks Yellowstone as a threat to human life in the lower 48? Have you ever visited Mount Rainier? Or do you live in one of the communities in its river valleys? Tell me what you know about the risk. If you want to be the first to know every time something like this develops, subscribe. It is completely free. A thumbs up helps enormously. Let us go for 5,000 likes on this one, so the algorithm shows it to people living inside the hazard zone who have never been told what is actually above them. Today we are going to break down exactly why the United States Geological Survey ranks Mount Rainier as the highest volcanic threat in the contiguous United States, what a lahar is and why it can happen without an eruption, and what 4 million people in western Washington need to understand about the 30-minute window. No guessing, no dramatizing, just the facts, the science, and the real stakes. Now, let us get into it. To understand why Mount Rainier is the volcano, the USGS loses sleep over, and Yellowstone is largely not. You need to understand what happened in the summer of 2026, and why it triggered an updated advisory from the Pacific Northwest Seismic Network that received almost no mainstream media coverage at all. Between May 19th and June 3rd of 2026, the PNSN recorded a sequence of 47 small magnitude earthquakes beneath Mount Rainier's summit, ranging from magnitude 0.8 to magnitude 2.4, clustered at depths between 1 and 4 kilometers below the ice-covered summit. These were not large earthquakes by any measure. A magnitude 2.4 earthquake is not felt by most people. But the depth and the location of this sequence, immediately below the hydrothermal system at Rainier's summit, where circulating hot water has been chemically weakening the volcano's internal rock structure for centuries, placed it into the category of monitoring signals that USGS Cascades Volcano Observatory scientists describe as requiring heightened attention. The PNSN logged the sequence in its monthly bulletin and notified the Cascades Volcano Observatory. No alert level change was issued. But the sequence joined a set of monitoring data points. Slightly elevated sulfur dioxide emissions measured by the USGS overflights in late April, continued ground deformation measured by GPS instruments on the summit plateau showing uplift of approximately 3 millimeters over the preceding 6 months, and persistent elevated temperatures at the Carbon River headwall, that collectively paint a picture of a hydrothermal system that is not stable and is not static. The USGS monitors Mount Rainier with 25 seismic stations, 9 GPS displacement instruments, and a network of acoustic flow monitors installed in the river valleys below the volcano. The acoustic flow monitors are particularly telling about what the USGS considers the primary hazard at Rainier. They are not designed to detect volcanic eruptions. They are designed to detect lahars, fast-moving flows of volcanic debris, water, and ice that can travel down river valleys at speeds between 20 and 40 miles per hour, filling valleys to depths of tens of feet with almost no warning. The fact that Mount Rainier's primary monitoring innovation is a lahar detection network rather than an eruption detection network tells you everything about which hazard the scientific community considers most imminent. That changed fast when the monitoring community reviewed the May-June sequence alongside the hydrothermal data. On June 12th, the Cascades Volcano Observatory issued an updated volcanic activity notice for Mount Rainier. Not an elevated alert level, but an internal scientific communication noting that the combination of shallow seismicity, slightly elevated gas emissions, and the GPS deformation data warranted closer monitoring of the hydrothermal system. The practical implication of that notice was a review of lahar response protocols with Pierce County and King County emergency management offices. Pierce County emergency managers conducted an unannounced tabletop drill on June 19th, specifically covering the scenario of a lahar reaching the town of Ording, Washington, with 32 minutes of warning. In the drill scenario, Ording's 8,000 residents had to reach the single 2-lane road leading out of the town's valley bottom to safe elevation before the simulated flow arrived. The drill result was not released publicly. But the county continued the drill cycle rather than standing down. The word lahar comes from the Javanese language and describes a volcanic mudflow, a mixture of water, volcanic ash, rock debris, and ice that behaves less like mud and more like fast-moving wet concrete. Lahars can be triggered by volcanic eruptions melting glacial ice, but they can also be triggered by steam explosions, hydrothermal collapses, glacial outburst floods, or the simple failure of a hydrothermally weakened slope that no longer has the structural integrity to hold together. That last mechanism is the one that keeps the USGS up at night when it comes to Rainier. The volcano's core has been infiltrated by acidic hydrothermal fluids for a very long time, and those fluids have converted the solid andesite rock inside the volcano into a soft, unstable clay material called hydrothermally altered rock. Hydrothermally altered rock does not fail gently. It fails in mass, quickly, and when it does, it picks up the ice and water above it and becomes a lahar without any eruption having occurred. The electron mudflow, which occurred approximately 500 years ago, is the clearest historical proof of this mechanism. That event buried what is now a significant portion of suburban Pierce County under 20 feet of volcanic debris. There was no major eruption associated with it. The volcano's weakened interior simply gave way. Now let us explain exactly what makes Mount Rainier's Lahar hazard so specifically and acutely dangerous, and why it is in a different category from any hazard Yellowstone currently poses to any comparable population. The first thing to understand is the ice. Mount Rainier holds 2.9 cubic kilometers of glacial ice, the largest glacial system on any single peak in the contiguous United States. To put that in context, 2.9 cubic kilometers is approximately 2.9 trillion liters of frozen water sitting on an active volcano at 14,000 feet elevation. When any significant fraction of that ice is mobilized, by an eruption, by a hydrothermal collapse, by a steam explosion, or by simple slope failure, it mixes with the loose volcanic debris on the mountain's flanks and becomes a lahar. The larger the initial ice mobilization, the larger and faster the lahar. What makes the Mount Rainier lahar hazard distinct from most volcanic hazards in the United States is that the trigger threshold is genuinely low. You do not need a Plinian eruption column. You do not need a lateral blast like 1980 Mount St. Helens. You need a hydrothermal collapse the size of a few city blocks to release enough meltwater to pick up the loose debris on the glacier surface and turn it into a flow. The electron mudflow, which occurred approximately 500 years ago, is the clearest historical proof of this mechanism, represents the upper end of what Rainier is capable of. That single event mobilized an estimated 3.8 cubic kilometers of material, larger than the volume of glacial ice on the mountain today, and traveled 68 miles from the summit, filling the valleys of the White River and Puyallup River to depths of up to 70 feet and covering 212 square miles. That deposit now underlies much of suburban Pierce County, King County, and portions of the Puyallup, Sumner, Ording, Enumclaw, and Auburn metropolitan areas. The communities that hundreds of thousands of people live in today were built on top of the debris left by the last time Rainier produced a major collapse event. People are, quite literally, living on the evidence of what this volcano can do. To put that scale in context, the 212 square miles covered by the Osceola mudflow would be enough to bury the entire cities of Seattle and Tacoma under volcanic debris. The Osceola event was not the result of a Yellowstone-style supervolcano caldera eruption. It was a single volcano's slope failure producing a lahar. That is the baseline capability of the hazard the USGS monitors above western Washington. The critical factor that makes Rainier more dangerous than Yellowstone right now. Not in absolute geological power, but in the specific, immediate, measurable threat to human life, is population proximity and warning time. Yellowstone's caldera is centered in a remote section of Wyoming. The nearest city of any significant size, Idaho Falls, Idaho, is approximately 110 miles from the Yellowstone caldera's edge. A Yellowstone caldera eruption would be catastrophic at a continental scale, but the immediate shaking and eruptive hazards would not strike a densely populated urban area in the first minutes. Rainier is 60 miles from the fourth largest metropolitan area in the western United States. The media ecosystem built around Yellowstone is not dishonest. It is covering a real geological phenomenon with genuinely extraordinary characteristics. What it has created, however, is a public mental model of volcanic danger in which the most spectacular geological structure is assumed to be the most dangerous. By that metric, a 14,000-foot stratovolcano covered in glaciers above a moderately sized river town in western Washington does not compete with a supervolcano the size of Rhode Island in one of America's most famous national parks. But by the metric that actually determines human harm. How many people are in the primary hazard zone, how fast the hazard moves, how much warning time they have, and how many of them can act on that warning in time. Rainier is not comparable to Yellowstone. It is categorically more dangerous by every measure that matters for the next event. The city of Ording, Washington, and the city of Idaho Falls, Idaho represent that difference concretely. One of them has 8,000 people in a valley floor with a 30-minute window and one road out. The other is 110 miles from a geological feature that has not produced a caldera eruption in 640,000 years. Population approximately 8,000 sits at the floor of the Puyallup River Valley in the direct Lahar flow path from Rainier's Carbon Glacier, with a single two-lane road connecting it to higher ground. USGS and emergency management modeling estimates that a Lahar from Rainier's summit would reach Orting in 30 to 40 minutes. At a Lahar travel speed of 35 miles per hour, that is not generous lead time for 8,000 people, many of them elderly or mobility limited, trying to exit via a single two-lane road with no alternative route. But the infrastructure impact of a major Rainier Lahar extends far beyond the immediate flow paths. The Puyallup River Valley carries interstate 5-lane highway routes, BNSF and Union Pacific rail lines, fiber optic and electrical transmission corridors, and water supply infrastructure for the greater Tacoma metropolitan area. A lahar that fills the valley to a depth of 20 or 30 feet does not merely destroy the homes in the inundation zone. It severs the transportation and utility infrastructure that the entire western Washington regional economy depends on. The Port of Tacoma, the second largest container port on the West Coast, handling over $12 billion in trade annually, sits at the mouth of the Puyallup River at Commencement Bay. A major Rainier Lahar delivering tens of millions of cubic meters of volcanic debris to Commencement Bay would bury port infrastructure under volcanic material and potentially affect the navigability of the port itself. The indirect economic impact would extend across supply chains that depend on the Tacoma port's throughput. A FEMA loss estimate for a major Rainier Lahar event, incorporating both direct damage and indirect economic disruption, has placed the total impact in the range of $10 to $30 billion, with recovery measured in years rather than months. And Orting is not the only community in the flow path. The Puyallup River Valley communities of Sumner, Puyallup, and Fife, with a combined population exceeding 130,000 people, are also within the mapped Lahar inundation zones for various scenario sizes. The White River Valley below Rainier carries comparable risk for Auburn and Enumclaw. The Cowlitz River Valley, draining the volcano's southern flank, extends the hazard into Lewis County. In total, USGS hazard planning documents identify approximately 150,000 people in the direct Lahar flow paths of a large Rainier event, and up to 4 million people in the secondary impact zone from infrastructure damage, ashfall, and economic disruption. 150,000 people in the direct kill zone, 4 million in the secondary disruption zone. Yellowstone's immediate death toll from a caldera eruption, if the population within the park itself were affected, would be measured in thousands, not hundreds of thousands, for the immediate flow zone. The numbers are not comparable on the human harm scale. But here is the thing about Yellowstone that makes the comparison complicated to communicate. Yellowstone is a genuine supervolcano with the capacity to alter global climate if it produced a full caldera eruption on the scale of its last major event 640,000 years ago. Scientists do not dispute that. What scientists consistently say, and have said for decades without contradiction, is that there is currently no scientific evidence that Yellowstone is approaching such an event. The annual probability of a Yellowstone caldera eruption is estimated by USGS at approximately 0.00014%, roughly once every 730,000 years based on the eruption frequency in the geological record. To put that in context, the probability that a given Mount Rainier Lahar significant enough to reach Orting will occur in the next 50 years is estimated by the USGS at roughly 1 in 7. These numbers are not comparable. The Yellowstone media ecosystem is covering an astronomical scale catastrophe with an astronomical scale recurrence interval, generating enormous viewership from a hazard that poses essentially no threat to any living human being. Mount Rainier is a 1 in 7 chance over 50 years for a lahar that would reach communities where people are sitting in their homes right now. The media ecosystem that has discovered Yellowstone has almost entirely missed Rainier. What scientists at the Cascades Volcano Observatory are watching right now, in the weeks following the May-June 2026 seismic sequence, is a set of signals that individually are within the normal background variability for an active volcanic system, but that collectively define the elevated monitoring posture the USGS has maintained on Rainier continuously since its last formal volcanic. Hazard assessment. The hydrothermal system at Rainier's summit is the primary focus. The summit plateau contains a network of fumaroles, hot springs, and steam vents that have maintained temperatures well above freezing, in some cases exceeding 80 degrees Celsius in the vent fluids, for as long as monitoring has been conducted. The chemical composition of those fluids is monitored for changes in sulfur dioxide and carbon dioxide concentrations, because increasing magmatic gas output is one of the signals that precede volcanic unrest at stratovolcanoes worldwide. The most recent USGS gas chemistry sampling, conducted by overflights in late April 2026, showed sulfur dioxide output slightly above the baseline established over the past decade. Not alarming in isolation, but consistent with the shallow seismic sequence's implication of increased hydrothermal activity. The acoustic flow monitors installed in the Puyallup, White, Carbon, and Cowlitz River drainages below Rainier are also generating regular data. These instruments, essentially sensitive microphones embedded in the riverbanks, can detect the low-frequency acoustic signature of a lahar within minutes of its initiation and relay that detection to Pierce County and King County emergency management agencies within roughly 2 minutes of the flow beginning. That 2-minute detection to notification window is the first entry in the 30 to 40-minute survival window for orting. After the notification, every subsequent minute is eaten by the time required to alert residents, for residents to act on the alert, and for the road network out of the valley to process 8,000 people simultaneously. Evacuation modeling consistently shows that 30 to 40 minutes is not enough time for full evacuation of orting under realistic traffic conditions. This is not a hypothetical planning concern. Pierce County has run the evacuation models. They have the numbers. The gap between the available warning time and the required evacuation time is a known and documented planning problem that has not yet been resolved. Keep an eye on the Long Valley caldera in eastern California, too. Long Valley is a supervolcano caldera in the Mammoth Lakes area of the eastern Sierra Nevada. Not Yellowstone, not Mount Rainier, but a volcanic system that produced one of the largest eruptions in the geological record of the western United States 760,000 years ago, and that remains seismically and hydrothermally active today. In 1980, the same year Mount St. Helens erupted in Washington. Long Valley experienced a series of magnitude 6 earthquakes that caused the USGS to issue an advisory noting that volcanic activity was possible. That advisory was eventually lifted. But Long Valley's resurgent dome, the area of elevated ground in the caldera center caused by magma inflation below, has continued to show episodic ground uplift and subsidence over the decades since. The town of Mammoth Lakes, with a population of approximately 8,000 residents and tens of thousands of seasonal visitors, sits inside the Long Valley caldera. Its geothermal hazard is real, it is monitored, and it receives approximately a fraction of the media attention devoted to Yellowstone. Yellowstone is the volcano people have heard of. Long Valley is the one in California's eastern Sierra that people from Los Angeles ski on. Here is where the science actually leaves us, and we have to state it precisely. Is Mount Rainier about to erupt? Scientists do not have evidence supporting that conclusion. The May-June 2026 seismic sequence was logged as elevated background activity, not as a pre-eruptive signal. The USGS Cascades Volcano Observatory alert level for Mount Rainier remains at normal, the lowest of 4 levels in the USGS system. Rainier has not produced a significant magmatic eruption in approximately 1,000 years. The monitoring data does not currently show the combination of large magnitude seismicity, rapid ground deformation, and sustained high gas output that the scientific community associates with approaching eruptions at stratovolcanoes. What scientists are saying is simpler and more immediate. The lahar hazard at Mount Rainier is real. It is measurable. It is higher in probability than any eruption scenario, and it can be initiated without any eruption occurring. The electron mudflow 500 years ago left no eruption layer in the geological record. It was a hydrothermal collapse of a weakened slope. That kind of event does not require the kind of pre-eruptive signals that allow months of public warning. It can happen on a timescale of hours to days of elevated seismic activity, which is exactly the timescale of the May-June 2026 sequence. The USGS did not issue a public warning during that sequence because the signals were within background variability. The USGS also conducted a quiet county-level emergency management review immediately afterward. Both of those things can be true at the same time. If you live in the Puyallup River Valley, the White River Valley, or anywhere in Pierce County or eastern King County within the mapped lahar inundation zones, there are 2 things you can do that the USGS specifically recommends. First, sign up for Pierce County's wireless emergency alert system and verify that your phone is set to receive emergency alerts, because the acoustic flow monitor network is connected to that alert system, and those alerts are the mechanism that delivers the 30-minute window. Second, know your high ground evacuation route and know it now. Not when the alert arrives, not when traffic is already gridlocked, but today. The communities in Rainier's flow paths are extraordinary places to live. But living in them without understanding the lahar evacuation plan is like living below a dam without knowing where the flood spillway runs. Drop a comment and tell me, did you know that the USGS ranks Rainier above Yellowstone as a volcanic threat in the lower 48? Do you live in Western Washington? Let me know what you know. And let us go for 5,000 likes so the algorithm puts this in front of the people in Orting, in Sumner, in Puyallup, and in Auburn who still think the volcano to watch is the one on the screensavers and the cable documentaries. See you in the next one.